Somewhere in southern China, a stretch of asphalt gets hot enough to leave a mark on bare skin, and it is still radiating that heat back into the air hours after the sun goes down. But walk 2 streets over, and you will find people standing under a fine white cloud that never actually touches them. It's a rooftop coated in paint that is somehow colder than the air around it, and an entire business district being cooled by a single machine buried several floors underground.
None of it is a conventional air conditioner. By the end of this video, you'll know exactly how it's engineered. China has just come through some of the hottest summers ever recorded on the planet. And instead of simply building more compressors and more refrigerant lines, its engineers went back to first principles and asked a completely different question. Not how do you make cold air inside a sealed box, but how do you stop an entire city from absorbing that much heat in the first place? The answer turned out to be a mix of cutting-edge material science, large-scale infrastructure, and one architectural trick that is roughly 1,000 years old. Together, these systems now cool streets, buildings, districts, and individual people, and almost none of it relies on the machine most of the world assumes is the only option. This matters more than it sounds like it should. Air conditioning already accounts for a massive share of electricity demand during a heat wave, so much that entire power grids strain and sometimes fail at exactly the moment people need cooling most.
China has hundreds of millions of people living and working outdoors, or in buildings that were never designed with modern cooling loads in mind. So the country has effectively become the world's largest live laboratory for figuring out how to survive extreme heat without simply scaling up the same energy-hungry machine everywhere. What has come out of that laboratory is a set of engineering solutions most people outside China have never even heard of. Start with the most basic ingredient in almost every one of these systems, and it is not a rare material at all. It is water. Specifically, water forced through nozzles narrow enough to break it into particles so fine that they behave almost like fog rather than rain. Producing that kind of mist is a precision manufacturing problem in itself. The nozzles have to be machined to extremely tight tolerances, because if the droplets are even slightly too large, they fall to the ground as ordinary water and soak everyone underneath. Engineered correctly, the droplets evaporate before they ever land, and that evaporation is the entire trick. Turning liquid water into vapor requires energy, and that energy is pulled directly out of the surrounding air. Multiply that across millions of droplets released over a crowded plaza, and you can measure a real drop in local temperature, often 5 to 8 degrees Celsius, in a space with no walls and no roof. A misting array needs almost nothing to run, beyond a pump and a water line, which means a city can cool an open-air market or a transit stop for a small fraction of what conventional refrigeration would cost, if refrigeration could even be applied to open air at all. But this is where things get interesting, because water is not the only tool China is using to fight heat at the scale of the entire atmosphere. During the record 2022 heat wave, when hydroelectric output in Sichuan collapsed and factories were forced to shut down, engineers turned to something far more dramatic than a rooftop system. They seeded the clouds. The material at the center of this process is silver iodide, a compound whose crystal structure is close enough to ice that water vapor inside a cloud will latch onto it and begin freezing around it. Once enough of those crystals form and grow heavy, they fall as rain. Delivering the silver iodide into the right layer of the atmosphere is its own engineering challenge, and China has thrown almost every available method at the problem, from ground-launched rockets to long-endurance drones built for exactly this mission, flying for hours and dispersing dozens of silver iodide flares across thousands of square kilometers of sky. It is not a guaranteed fix. Cloud seeding only works when there is already moisture present, and it cannot summon a storm from a clear sky. What it can do is tip a stubborn, moisture-laden atmosphere over the edge, cooling the air directly and refilling the reservoirs an entire region depends on. However, the next stage on this list did not come out of a lab or a drone command center at all.
It came from architecture that predates electricity by centuries. Walk into a traditional courtyard house in the old Huizhou region, and you will find a tall, narrow shaft running straight up through the center of the building, open to the sky. It is called a tianjing, or sky well, and it looks decorative until you understand the physics underneath it. The walls surrounding that shaft block direct sunlight from ever reaching ground level, so the air down there stays cool and dense. Warm air inside the house naturally rises and escapes out through the opening at the top, the same way heat escapes up a chimney. And as it leaves, it pulls cooler air in behind it through the lower rooms. No fan, no compressor, no electricity, just the geometry of the building doing continuous, silent work. Engineers studying these homes have measured interior temperatures running several degrees below the outside air on a hot afternoon. And the idea has now been scaled directly into modern construction. In Guangdong, a tower of dozens of stories was built with internal vertical channels that move air through the structure using exactly the same stack effect principle that has been cooling rural courtyard homes for 1,000 years. At this point, one tiny mistake could ruin the entire result. And that is exactly the problem with the material sitting under almost every road in the world. Ordinary black asphalt reflects only around 5 to 10% of incoming sunlight, meaning it absorbs the rest. Climbing past 60 degrees Celsius on a summer afternoon, and then radiating that stored heat back out long after sunset. That is a major driver of what scientists call the urban heat island effect, where a city stays measurably hotter than the countryside surrounding it, especially overnight. Chinese cities, including Guangzhou and Shenzhen, began resurfacing major roads with what engineers call cool pavement, a layered approach combining solar reflective coatings that bounce sunlight back into the sky before it can be absorbed, thermal blocking layers that slow heat from penetrating deeper into the road, and porous materials that hold moisture so the surface can shed heat through the same evaporative principle used in outdoor misting systems. Field measurements on these coatings have recorded surface temperature drops of roughly 7 to 14 degrees Celsius compared to standard asphalt under identical sun exposure, a change that adds up fast once it is applied across every major road in a city. Now, for the most impressive part, and it is genuinely difficult to believe the first time you hear how it works, it is a paint. You brush it onto a rooftop, and the building underneath gets measurably colder, with no wires, no power source, and no moving parts. And it keeps working while sitting in direct, blazing sunlight. The technology is called passive radiative cooling, and it does two things simultaneously. First, the coating is engineered to reflect nearly all incoming sunlight, so very little solar energy is absorbed in the first place. Second, and this is the genuinely clever part, every warm surface constantly radiates heat as infrared energy, but most of that radiation gets reabsorbed by the atmosphere and everything nearby almost immediately. There is, however, a narrow band of infrared wavelengths the atmosphere is essentially transparent to, and this paint is engineered to emit its heat precisely within that window. Radiation released at those wavelengths passes straight through the sky and escapes into deep space, which sits at a temperature near absolute zero. In effect, the coated surface uses the entire universe as a heat sink, 24 hours a day for free. A commercial version developed out of Hong Kong has cut rooftop surface temperatures dramatically and pushed indoor temperatures down by roughly 10 degrees Celsius, translating into cooling energy savings that can approach 40%. And it has since been applied across hundreds of buildings in dozens of countries. Quality control for a system like this is unusually strict because a coating that fails to hit its precise infrared emission band simply stops working as advertised. So every production batch is tested against calibrated solar simulators and thermal imaging before it ever reaches a rooftop. The same obsession with verification shows up at the district scale. In the Qianhai area of Shenzhen, engineers built what amounts to a single enormous chiller buried several floors underground, a facility one visiting journalist compared to a factory rather than a mechanical room, filled with pipes, pumps, and chillers spread across an area the size of a football field. Instead of thousands of individual buildings running their own separate air conditioning units, chilled water is produced centrally and pumped through insulated pipes beneath the streets to building after building, each one tapping into the network the way a house taps into a municipal water line. The consolidated system is reported to save around 130 million kilowatt hours of electricity every year, the rough equivalent of not burning 16,000 tons of coal,
while also sharply cutting the refrigerant leakage that comes with running thousands of smaller, separate units. And the scale of all this stretches from the sky down to a single human body. Solar-powered outdoor cooling units are now appearing at bus stops and public squares across Chinese cities, generating streams of cool air exactly where people are standing and waiting, powered by panels that happen to produce the most electricity at precisely the moment the heat is worst. The smallest link in the entire chain is a wearable device curved around the neck, using a solid-state cooling chip to pull heat directly out of the skin at one of the points where blood runs closest to the surface, alongside battery-powered cooling vests and handheld misting fans. These are not novelties. In a country where enormous numbers of people work and commute outdoors through extreme heat, a cheap, portable device that keeps a person's core temperature in a safe range functions as genuine protection against heat stroke, reaching people no rooftop coating or underground plant ever could. What ties all of it together, from silver iodide dropped from a drone to a single wearable chip against someone's neck, is a shift in how heat itself gets treated. Instead of treating it as a private problem, solved one sealed room at a time, Chinese engineers have started treating it as public infrastructure, built into roads, rooftops, districts, and clothing, the same way a city builds its water lines. Which of these would you actually want built into your own city? The mist that cools a street without soaking anyone in it? The paint that cools a building for free? Or the small device that fits around your neck? Tell us in the comments. And if this changed the way you look at the road under your feet, hit subscribe so the next one finds you.